For decades, opening a blank code editor meant confronting a massive barrier. You had to memorize exact syntax, track down misplaced commas, and type every character by hand. Today, that blank screen is a conversation starter. You type a prompt, and the underlying logic appears instantly. Building a production-level application used to require a team or months of solitary focus. You had to master complex architectures like MVC, untangle state management protocols, and manually design user interfaces before you ever saw a working prototype. The process of software development has shifted. You are no longer required to act as the manual typist. Instead, you step into the role of a director, guiding an AI through the structural requirements of your application. The technical friction that kept beginners out is gone. The challenge now is communication. Success depends entirely on your ability to clearly articulate your vision and direct the AI to execute it. This diagram maps the 6 stages to build an app: idea, UI design, code, backend, debugging, and deployment. We'll apply this framework to build an anime streaming app. Notice how the AI partner injects directly into each node, generating layouts, widgets, and backend logic. If you attempt to generate code before defining the architecture, the AI will produce fragmented, unusable scripts. Mapping out this lifecycle ensures your inputs remain focused and logical at every step. When developers first try building apps with AI, they often type a basic idea and expect a complete application in return. This creates a prompting gap. Vague instructions force the AI to guess your intentions, resulting in broken logic and fragmented code. This diagram shows how linguistic structure translates into software architecture. A strict prompt isolates the requirements into layers. You explicitly define a dark theme for the base, a bottom navigation bar for the boundary, and a horizontal scroll for the content categories. By breaking the prompt down into these specific rules, the AI stops guessing. It processes those parameters and converts directly into a clear component hierarchy, stacking them exactly as you instructed. Building a stable interface starts long before you open an integrated development environment. It requires defining your structural constraints through clear, rigid language. Even with a perfect prompt, copying the resulting thousands of lines of code and pasting them into your editor can trigger immediate panic. The file looks dense, complex, and unreadable. This diagram shows how the Flutter framework organizes that complexity. Instead of a monolithic wall of text, the code collapses into isolated modular building blocks called widgets. You have a scaffold block for the base, an app bar block for the header, and a list view block for scrolling. You don't need to read every character of the syntax. You simply take these prefabricated functional units and snap them together to form the visible layout of your home screen. Your role shifts from writing the underlying rendering logic to managing the assembly line. You instruct the AI to generate the specific widgets, and you ensure they fit neatly into the broader structure. A visual interface is an empty shell until it has data to display. To manage user profiles, authenticate logins, and stream video content, you have to connect your front-end layout to a back-end database, like Firebase or Supabase. This glowing red screen shows the inevitable point of failure in any development cycle. When the backend sends an unexpected data format, or a widget overflows its boundaries during an API fetch, the application crashes and throws a wall of error text. Look at that error. How do you resolve it? Instead of manually hunting through the codebase for a missing comma or a broken variable, think about how you can leverage the AI. What specific information does it need to fix this crash? The most efficient workflow is direct translation. You copy the exact raw error code from your console and feed it back into the AI. You ask it to explain why the failure occurred in plain language, and you request the corrected widget syntax. A red screen is no longer a dead end that stalls progress for hours. It is diagnostic data you use to prompt the next iteration of your AI conversation. Through iterative prompting and debugging, the application takes shape. The layout components function as intended, the horizontal category banners scroll smoothly, and the active video player pulls content cleanly from the database. Reaching a stable build is only the technical threshold. The AI continues to accelerate the process by generating optimized store listing descriptions, structuring release notes, and mapping out search optimization strategies for the Play Store. This diagram maps out the 4 foundational rules of this workflow. Treat the AI as a collaborative partner. ensure every prompt carries deep structural context, handle debugging conversationally by feeding errors back into the chat, and prioritize iterative speed over manual perfection. The friction of syntax and complex tooling has been drastically reduced. The developers who build at scale moving forward will be those who combine their own creative direction with the immense execution speed of artificial intelligence.